Okay, so we were doing Laplace transforms and a few questions on it. And today we are going to explore more on these things. So let me wait for a few people to join in, and then we'll start. And right now we are doing questions on Laplace transform. Once we are acquainted with all these things, then we are going to address the main question, that is how to find the solutions for the ordinary differential equations using Laplace transform. Okay, so that would be a very important thing to do. Bharat, is that clear? The question was clear to you? Is it clear to you, Bharat? Okay, so we are right now doing questions of Laplace transform where we have to use Heaviside function, because I found in my experience that people usually can do all these questions. The questions where you have some elementary transform, Laplace transform of elementary functions, that is quite easy to do. And similarly, Laplace transform, inverse Laplace transform of all those functions is quite easy to do. But now, if I use some Heaviside functions and unit step function, then things become certainly difficult. So therefore, I'm paying more attention to it. Now try to do this question. Probably I have made you do this or not made you do this. If I have made you do this, it will be revision for you. And if I have not done it for you, then kindly do this. Okay, so I'm giving you a minute, try to do this. Is that clear? Should I start? So I've told you how to go about this problem again. So I know that slightly it may be difficult for you, but let me see. Answer to this is, so explain that. So okay. So how would you go about it? So where is the marker? Here. Okay. Okay. So, Bharat, am I audible?
Yes, sir.
Okay, okay, good. So how to go it? How to go about it? I'll write ft is equal to sine 2t h of t minus h of t minus pi, right? So you know that for t greater than 0, this would be 1, and t less than pi, this would be 0. So this is 1 minus 0 is 1. So you will get sine 2t. And for t greater than pi, this would be 1, this would be 1, 1 minus 1 is 0. Okay? And if you want to find the Laplace transform of ft, it will be equivalent to finding Laplace transform of sine 2t into h of t, and then minus Laplace transform of the sine 2t into h of t minus pi. Okay, and this would be equals to e to the power minus 0s, that is 1. And what is sine 2t? The Laplace transform of sine 2t is equals to what? It is equals to 2 upon s square plus 4. Right?
Yes, sir.
And minus e to the power minus 5s 2 times divided by s square. I hope it is clear. So you can take things common, then it will be 1 minus pi e to the power minus pi s times 2 upon s square plus 6. So you should take those questions or कर लो so that you will get an idea of. And you can find these questions probably in any of the standard engineering mathematics texts. So you can take in Irvin Krasik, or you can take H.K. Das, or you can take any of the engineering mathematics, because engineers mostly are concerned with this transform theory because it is quite useful for them in their signals and systems and subjects like those. So engineers mostly, when it comes to mathematics or engineering mathematics, they mostly study transforms. Engineers. So in any of these book of applied engineering mathematics, you'll find all these questions, and probably of much better level uh, than what is asked on our side. Okay. Okay. So try to do this question. Now, if I'm giving you a ft as simply cos t for t lying between 0 and pi, and t greater than pi के लिए हम लोग लिख देते हैं sin t. Try to first write the definition of the function in terms of Heaviside function, and then try to write your Laplace transform. So clearly from the above examples, we know that if I want to write cos t would be cos t into ht minus cos t into h of t minus pi, right? And then plus sin t h of t minus pi. If I'm not wrong, just try to cover this definition if that's not right. If let's see. So if
Yes,
t is greater than 0, if t is greater than 0 and less than pi, if t is greater than 0 and less than pi, this would be 0. This would be 0, simply cos t you will get. Okay. And if t is greater than pi, this will be cos t, this will be minus cos t, and this will be sin t. You will get sin t. Now, if you want to find the
sir.
Laplace transform, beta बोलो.
Sir, in above example, the second term, we have to get sin 2t in terms of t minus pi only, no? वैसे करके प्रोसीड किया है तब हमें ये आंसर मिला है ना
हाँ
या
सॉरी
आपने
सॉरी
डायरेक्ट
नहीं कोई अब क्या आदत बन गई ना मेरी. हाँ, तो दैट इज बिकॉज यू नो दैट योर साइन गुड पॉइंट ना. सो साइन 2t minus 2 pi, because if you replace t 2t minus pi, sorry, my mistake. ठीक है, तो ये हो जाएगा 2t minus 2 pi, which is equal to what? It is equal to minus of sine of 2 pi minus 2t, and sine of 2 pi minus 2t is minus, so again it will come as sine 2t. Okay, so good point. Right. So you have to remember that this is because we have written in this fashion, because you see we have to somehow put our terms in terms of t minus pi. Only then we can use that property. Okay, the property that we've right. Okay. Should I move ahead now?
yes sir.
Okay, good enough. So now it will be cos of t. So ये तो कोई दिक्कत है ही नहीं, यहाँ दिक्कत आएगी. Cos of t minus pi लिखो चाहे pi minus t लिखो, बात एक है. और cos of pi minus t होता है minus cos t. Is that clear?
यस सर.
है ना. और एक टर्म हो जाएगा तुम्हारा साइन टी माइनस पाई. तो ये हो जाएगा माइनस साइन ऑफ टी माइनस पाई, बिकॉज साइन ऑफ पाई माइनस टी साइन टी. साइन ऑफ टी minus pi would be minus sin t. Okay, so if I take the so this is Laplace transform of all these things. So Laplace transform of cos t simply s upon s square plus 1. What is this? This would be, I think, again s upon s square plus 1. Only e की power minus pi s would come in excess, and then there would be minus 1 upon s square. This is e की power. Okay, so if I take this all क्या कह सकते हैं, 1 upon s square plus 1 common out. So what I'll get, I will simply get s plus s minus 1 into e की power. Is that clear? इसमें कुछ गलती तो नहीं करी ना?
यस सर.
ठीक है, डन. आई थिंक इट इज क्लियर. समझ में आ गई मेरी बात? तो इस तरीके से यू आर गोइंग टू डू क्वेश्चंस व्हेन इट कम्स टू हेविसाइड फंक्शंस. तो क्या थोड़ी लाइफ इजी हो जाएगी इन दीस क्वेश्चंस. Okay. Now, one thing that we were doing yesterday, and we figured out that somehow we figured out the answer using the Heaviside function. But today, let us develop a more generalized approach. So let us first do Laplace transforms of periodic functions. And you can see that why I'm not paying much attention to inverse Laplace transform. So, for example, if you know how to find Laplace transform, inverse Laplace transform is not that difficult thing, because after all, it is just an inverse of it. So, if you know that whose Laplace transform is the given function, then you know the Laplace inverse of that particular function. So, you have to pay much attention on finding Laplace transform. And one particular thing I'll teach you extra, which is not in your syllabus as such, that is called as finding Laplace inverse using Bromwich integral. So that is again a complex integration. So without proof, I'm going to state you something. And since you know complex integrations, so you'll be able to find inverse Laplace transform there also. And a few more things also. So probably tomorrow would be the last class, mostly last class. And after July, in any way, I'll start quantum mechanics. So don't worry. So still July, I have some research work pending. So okay. So let us consider that function ft is periodic with period omega. So when I say that my function is periodic, that implies if I add my omega to the argument, that is t plus omega, then my function would be simply ft. So a function which is periodic with period omega, I can write it in this fashion. And also remember that if omega is the period, then n omega is always a period. So if I say that my function sin x has period 2 pi, then the period of sin x would be sin 2 pi n also. Like what I want to say is that if my period of sin is 2 pi, then 2n pi is also a period. This particular is called as the fundamental period. That is the smallest one of them. Is always a period. Is that clear? यहाँ तक समझ में आ गई बात? So if I'll write, so therefore I can write my ft plus omega 2 omega. If you write ft plus 3 omega, that is also right. All these things, ft plus n omega, all these things are going to be equal to what? It is going to be ft. Is that clear, बेटा? ये चीज समझ में आ गई आपको?
Yes sir.
So what I'll do, I will now try to find the Laplace transform of this particular function. So from 0 to infinity e की power minus st ft dt I'm going to find. And what I'm going to do, I'm going to divide it into like wherever your function is period. So this is how it is, from omega to 2 omega. This is omega. Okay. Again, e की power minus st. And now I'll do it in the later step. चलो एक बार लिख लेते चीज को. Therefore, here I'm going to e की power minus st and ft dt. 10 plus integration 3 omega to 4 omega e की power minus st, then you have this term ft, और इस तरीके से आप चलते ही जाओगे. Is that clear? Now, if you want to write integration 0 to infinity e की power minus st and ft dt, what it will be equals to? It will be equals to 0 to infinity, और फिर मैं क्या कर रहा हूँ 0 to ओमेगा लिखा मैंने e की power minus st ft dt. Is that clear? अब थोड़ा ध्यान से देखना, यहाँ t की जगह what I'll do, I'll replace 0 to infinity e की power minus st, 0 to infinity नहीं 0 to omega, and I'll replace it by f of t plus omega, और यहाँ पे dt आ जाएगा, या फिर तुम चाहो तो यहाँ z plus omega लिख दो, dz आ जाएगा, then again you can replace z by t. Should I write z and then do it, or is that understood? देखो, इस जगह पे मैंने t की जगह रिप्लेस कर दिया z प्लस ओमेगा, मानो अगर ऐसा कर दिया तो ये क्या हो जाएगा, dz हो जाएगा, और ये हो जाएगा एस जेड, एस मतलब z प्लस ओमेगा यहाँ पर क्या आएगा. चलो मैं कर ही देता हूँ, जल्दीबाजी नहीं करता हूँ, जल्दीबाजी में काम बेकार हो जाता है, 2 मिनट चीज. So what I'll do in the second integration, I'll replace my t. Okay, so I'll replace my t by z plus omega. So I'll do it e की power minus s z plus omega, and then I have this f of z plus omega, and this is fz. And what would be the limit? The lower limit would be what? I think 0. Upper limit would be omega. Is that clear? Bharat, is that clear?
Yes, sir.
Okay, good. अब एक काम करते हैं, यहाँ पर f of z plus 2 omega लिख देते हैं. Again, this dt would be dz only, and this would be e की power minus s z plus 2. And again, this is from 0 to omega. Is that clear? And you keep doing all these things, and at the end, here I will get again 0 to omega, and I'm here writing e की power minus s z plus n minus 1 omega, and then this is e की f of t plus n minus 1 omega, z dz. Is that clear? आप खुद सोचो, फंक्शन क्या पीरियोडिक है, तो एफ जेड प्लस ओमेगा लिखो, चाहे एफ जेड प्लस 2 ओमेगा लिखो, चाहे एफ जेड प्लस एन माइनस 1 ओमेगा लिखो, ये सब एफ जेड हो जाए. दिस इज व्हाट आई हैव रिटन. एफ टी प्लस ओमेगा लिखो, चाहे एफ टी प्लस 3 ओमेगा लिखो, चाहे एफ टी प्लस एन ओमेगा लिखो, ये सब क्या हो जाएगा, एफ टी हो जाएगा. तो ऑल दीस थिंग्स वुड बी एफ जेड ओनली. सो व्हाट आई एम गेटिंग 0. एक काम करो, यहाँ पर भी टी को जेड से रिप्लेस कर दो, सिंपली रिप्लेस इट बाय जेड ओनली. सो इट विल बी 0 टू इंफिनिटी e की पावर माइनस एस जेड एफ जेड डी जेड. इज दैट क्लियर?
Yes, sir.
है ना. प्लस अगेन यू सी, एक इनमें से कॉमन बाहर आ जाएगा, तो जाएगा e की पावर माइनस एस ओमेगा फ्रॉम 0 टू ओमेगा e की पावर माइनस एस जेड एफ जेड डी जेड. बिकॉज यू सी एफ जेड प्लस ओमेगा लिखो चाहे एफ जेड लिखो, बात एक ही होगी ना, बिकॉज एफ जेड इज आफ्टर ऑल पीरियोडिक विद पीरियड ओमेगा. So, and this is e की power minus 2s omega, and then you have this 0 to infinity f z dz, all those things. This is e की power minus n minus 1 s omega, integration from 0 to infinity. Oh, I have forgotten right? This e की power minus sz fz dz, and so on and so forth. All these things will go carry. ठीक है, कोई दिक्कत इसके अंदर?
Yes, sir. Clear.
Okay, and this is equal to what? This is equal to Laplace transform of ft, and let us denote by fs. So fs is equal to what? Fs is equal to, this is again Laplace transform of fs, and this is, I think, अच्छा, sorry, ये 0 टू इंफिनिटी नहीं है, ये 0 टू ओमेगा है। कोई सोचो क्या गलती हो रही है, सॉरी, है ना। तो लैप्लस ट्रांसफॉर्म ऑफ एफ एस विच इज एफ टी इज इक्वल टू integration from 0 to omega e की power minus st ft dt. Again, you can try to use the t variable only. 1 plus e की power minus s omega plus e की power minus 2s omega plus dash 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 e की power minus n s omega dash dash dash. There are infinitely many terms. Is that clear? So integration from 0 to infinity e की power minus st ft dt, which is the Laplace transform of ft, it is equal to, this is what it is going to be. It is going to be 1 upon 1 minus e की power minus s omega, and integration from 0 to omega e की power minus st ft dt. Don't forget this is omega, okay? Which is the period of the function. So this is an important formula. अगर ये कर लिया, then you are not supposed to find क्या कह सकते हैं, you are not supposed to write your function in terms of a Heaviside function. Rather, you can use it directly. All you need to know is that what is the period of your function, what is the fundamental period of your function. Will that do? मतलब ये चीज समझ में आ गई?
Yes, sir.
Okay, so let us do one of the exercise where we are supposed to find the Laplace transform of a half wave rectifier. So find the Laplace transform of a half wave rectifier. So you know that half wave rectifier is represented by ft is equal to, simply you can take it as sine omega t in one of the periods, and otherwise is 0 uh, in half of the cycle. Okay, so instead of t upon, it is usually t 0 to t range from 0 to pi. Rather, I have written omega, so I'm going slightly changing the range. Is that clear? Now you have to find me the Laplace transform of this particular function. Find me the Laplace transform of this particular function, which is represented, which is usually referred to as half wave rectifier. I'm giving you almost 1 minute, 1 or 2 minutes. Try to do this. first thing that you need to understand is that whenever your function ft is periodic with period t, so if your function has a period t, and if I'm asking what would be the function of period at plus d, then always remember this will be t upon modulus of it. This is the first thing that you should understand. Okay, in order, first you need to find what is the period of sine omega t. So what do you write? I will write that the fundamental period of sine omega t is simply 2 pi upon omega. Is that clear? This is the first thing that you should write. So instead of like omega here, I will write 2 pi by omega. Is that clear to you? This omega
Yes,
here
yes.
is to refer to the period t. So यहाँ पे हम क्या लिखेंगे? I want to find the Laplace transform of this particular function, which is represented by half wave rectifier function. So this is 1 minus e to the power minus 2 pi upon omega, and then I have to find integration from 0 to 2 pi upon omega. This is e to the power minus st, and this is ft. And from 0 to pi upon omega, you have something, but from pi upon omega to pi upon omega to 2 pi upon omega, you have the 0. So after all, we have to integrate it from that part. So I'll integrate it 1 minus 2 pi upon omega, integral from 0 to pi upon omega, e to the power minus st, and I think that was sine omega t f t t. Is that clear? And a day before yesterday, I did the integration for it, so I'll have to do it all over again. So 1 upon d e to the power minus st sine omega t. So this is equal to what? It is equal to 1 upon d minus s e to the power minus st sine omega t multiply by d plus s. So I'll get e to the power minus st d plus s all above and below. You get d square minus s square. And here you have sine omega t. Instead of d square, you have to replace minus omega square. So e to the power minus st d plus s divided by minus omega square plus s square. And this is sine omega t here. And what it will be like. So I'll write this particular integration would be equals to e to the power minus st. What is the derivative of sine omega t? This is omega cos omega t. And then plus s into sine omega t. And a negative sign is obviously there. So I'll take a negative here. And this is omega square plus s square. Is that clear? So all I have to do is put in limits now. So my Laplace transform of the function, which is represented as a half wave rectifier, is given by 1 minus e to the power minus 2 pi upon omega. And then this is equal to e to the power minus st divided by omega square plus s square. And then you have omega cos omega t. And then you have this plus s sine omega t. And then you have this instead from 0 to pi upon omega, and write pi upon omega 2. Okay. So in place of t, you have to place 0. So in place of t, if I place 0 here, and if I place 0 here, so what I'll get? If I place 0 as well. So first thing that I'm going to get is 1 minus e to the power minus 2 pi upon omega. See, if I place pi upon omega, so sine pi is 0, right? Sine pi is 0. Cos pi is minus 1. And this is something e to the power minus. I think there is some mistakes there. I don't. अच्छा यहाँ पर भी तो एक s आना चाहिए है ना, s ओमेगा होता है. Sorry. लेकिन यहाँ पर भी एक s आएगा. Here s would come. Okay. Now here an s would come. And here an s would come. Okay. So e to the power minus pi upon pi s upon omega, and there would be omega square plus x square. So I'll write that part. I'll write it here because you have to place limits on t, and then this would be some negative term as well. Because this is minus 1 and minus of this. So you'll get, I think, minus, this will be minus, And then if I place 0 also, तो 0 में क्या होगा, ये हो जाएगा e की power 0 is 1, and this would go 0, and this would be minus omega. Again omega would come. I'll let omega common out, and this would be. Is that clear? कोई गलती कर रहे हैं तो प्लीज देख लो एक बार. 0 to pi upon omega की जगह एक नेगेटिव ये रहा, सॉरी, एक नेगेटिव ये तो है. So this negative will absorb these things, isn't it? देखो ये एक नेगेटिव यहाँ पर भी तो था. This negative will also absorb this. Finally you will get what? You will get 1 upon 1 minus e की power minus pi upon, देखो ये क्या है, 1 minus x square, और ये 1 plus x है तो 1 minus x रह जाएगा नीचे, ओमेगा आ जाएगा यहाँ पर, and omega square plus x. Is that clear? So your Laplace transform of Laplace transform of a half wave rectifier, this would be the answer. Is that clear or not clear? ये चीज समझ में आई नहीं है. भरत, is that clear?
Yes, sir.
Okay.
सर इसको हमने हेविसाइड फंक्शन के टर्म्स में नहीं लिखा फंक्शन क्योंकि पीरियोडिक है इसलिए.
राइट राइट. तो कल हम लोगों ने पीरियोडिक फंक्शन को हेविसाइड फंक्शन के फॉर्म में लिखा था, आपको ऐसे ही कुछ किया था हम लोगों ने, राइट? एक हाफ वेव रेक्टिफायर जैसे तो लिया था, एक स्क्वायर वेव इनपुट ही तो ली थी, एक एम्पलीट्यूड की, याद करो. तो वो एक मतलब एक लंबी प्रक्रिया नहीं हो जाती, मतलब एक लंबा सा काम हो गया. सो if you know the fundamental period of the function, then you can straightway use this formula. So this is what I was telling you yesterday also. Okay, tomorrow, that is the other day, I'll be telling you the Laplace transform periodic function. So it is an easy way to do.
Oh yes sir.
Okay, instead of using all those things, मतलब वो आपने देखा ना, तो हम लोगों ने किया था पिछले एक दिन पहले. Okay, is that fine? ये चीज समझ में आ गई?
Yes sir.
Now one needs to see what would be the Laplace transform of Dirac delta function. And from here, I'll sum up the class, and then we'll continue to go. Laplace transform of a Dirac delta function. Laplace transform of Dirac delta. So how to find those things? So for example, if you have a Dirac delta function stationed at a, where a is greater than 0, where a is greater than 0, I have to find the Laplace transform of this particular function, Dirac of t minus a. So by filtering property, I can clearly do it from 0 to infinity, e की power minus st Dirac delta t minus a and dt. I think it would be easy to find that this would be equals to what? It will be equals to e की power of minus of as. Is that clear? Provided a is greater than 0. If a is less than 0, then the answer would be 0. Are you getting my point or not getting it? What I want to convey. Is that clear?
Yes sir.
Okay. So it is Laplace transform of a Dirac delta function stationed at t equal to, and if I want to write what is Dirac delta function stationed at t equal to 0, what is the Laplace transform this? Laplace transform for this would be equals to what? It will be equals to 1. E की power 0 is 1. Is that clear?
Yes sir.
Okay. Now just try to do a question, and then we'll conclude this lecture. Okay, for that I'll need to do something else. Okay, take काम करते हैं, 2 questions on करते हैं, then we'll conclude the lecture, so that अब कल करेंगे बाकी सारे नए topics, because now there are 2 difficult topics left, and I think there's not much time left. So I'll make you do a few questions, and then since we've done quite amount of questions on Laplace transform, let us do a few questions on inverse Laplace transform. Find inverse Laplace transform of ln if we log to the base e s plus b divided by s plus a. You have to find this thing. You have to find inverse Laplace transform of ln of s plus b divided by s plus. Okay. How would you do? I taught you today itself that no such function you would have found whose Laplace transform corresponds to log. So the best strategy is to differentiate. The best strategy is to differentiate. So let us write fs is equal to what? It is equal to log to the base e s plus b minus log to the base e s plus a. And now if you differentiate it, what you'll get? You'll get simply 1 upon s plus b minus 1 upon s plus a. And now if you want to take a Laplace inverse of it, Laplace inverse of f dash s, which is equals to minus t ft, is equals to what? It is equal to e की power of minus bt minus e की power of minus at. Is that clear? So what would be your ft? Your ft would have been simply e की power minus at minus e की power minus bt divided by t. Is that clear?
Yes, sir.
Okay. Try to find this then. Try to find the Laplace inverse of, you have to find the Laplace inverse of s upon s square plus a square का whole square. So I'll do it for you, don't worry. This is slightly difficult. So देखो एक चीज मैंने सिखाई थी कि the Laplace transform of ft upon t, provided the Laplace transform of ft exists and the limit to the right of t equal to 0 exists, is given by integration s to infinity f s dash ds dash. Is that clear? And you can see that this is going to trouble you because here there are power of 2. Base में देखो power 2 चल रहा है denominator. So what I'll do, instead of doing this, I'll integrate this from s to infinity. I'll write s dash divided by s dash का square plus a square का whole square. And I'll write 2 here, I'll divide it by 2 here, I'll do a ds here. And I will try to find what is this. What is the Laplace inverse of this? So Laplace inverse of this would be ft upon t, right? Is that clear or not clear? देखो मैं क्या कहने की कोशिश कर रहा हूँ, मैं ये कहने की कोशिश कर रहा हूँ, if I want to find the Laplace inverse of this, so I'll write that Laplace inverse of s upon s square plus a square का whole square is simply, let's say, ft, and I'm not able to solve it. So what I'll do, I'll try to find an integration for this. If I, so this is what, this is your fs only. fs का इंटीग्रेशन अगर करोगे 0 से s से इंफिनिटी के बीच में, तो वो क्या आ जाएगा, ft upon t के बराबर आ जाएगा. Laplace transform of ft upon t is इंटीग्रेशन, और इसका इंटीग्रेशन करना आसान है, एटलीस्ट एक पावर तो कम होगी इससे. तो इट इज इक्वल्स टू Laplace inverse of 1 upon 2 बाहर ले लो. This integration would correspond to what? I think minus 1 upon s square plus a square from s to infinity, right? और s to infinity करने के बजाय तुम एक काम करो, infinity to s कर दो, infinity पे 0 हो जाएगा, and it will be simple. It will be ft. Is that clear? देखो इसका इंटीग्रेशन, तो इसका डेरिवेटिव ऊपर बैठा हुआ है, तो आई थिंक माइनस 1 अपॉन एस स्क्वायर प्लस ए स्क्वायर आ जाएगा, ठीक है. एंड देन इफ यू प्लेस दीज लिमिट्स, this is something that you get. And you know that from the bracket, inside this particular bracket, you know this is what, this is the Laplace inverse of what? It is a Laplace inverse of sine at upon a, isn't it? If you do an a here, which is equal to ft upon t. So here you can find your ft, that is the Laplace inverse of your given function, simply t upon 2a sine at. Is that clear?
Yes, sir.
Slightly difficult approach, but something, again, you have to learn all these things. So, okay, so we'll meet tomorrow in any case, and we'll try to finish this topic in tomorrow's time. Okay.
We